Page 13 of our Unit 4 packets, and we're going to be talking about composite functions today. So a composite function combines functions where the input from one is the input from another function. So I have two steps outlined here, and you guys can read that later if you would like things outlined in steps. I'm going to go through a couple examples. So a composite function is combining two functions. So I have an f of x function and a g of x function. Now, part A says f of g of x, and that's how we say this. F of g of x. So another way to write this, some notation is this empty circle. And another notation is f of g of x, where the g is inside parentheses there. And I'm actually going to use this notation. I'm a fan of this notation better, but I just want you guys to know both notations. So this notation means the same as this. So for part A, I want f of g of x. So the first thing that I'm going to do, always go from the inside out. Inside out. Sorry, that's really annoying. Okay, it's impossible to record here without having that happen. So g of x, I'm starting from the inside. That's my g of x. I'm going to replace this. I know g of x is equal to x squared plus 1. So that means my g of x completely goes away, and I'm replacing it with whatever g of x equals. So f of x squared plus 1. Now this is exactly like evaluating functions that we did the previous day. So now, since I'm going to take my f equation now, I'm completely done with my g of x. Now I'm going to f of x. 5 times x. Well, I know that x is going to go away. I'm replacing this x squared plus 1 with the x. So the x completely goes away. I still need my parentheses, so this is going to equal 5 times x squared plus 1. From here, my last step is I distribute the 5. And I have 5x squared plus 5. I can't combine like terms, so that is my answer. Okay, now let's go to part B. Part B is the opposite. So g of f of x. I like to write that as g of f of x. But if you guys like this notation better, then that works also. So again, I'm going to go from the inside out. So if I have g of f of x, the first thing I'm going to do is the inside. So I'm going to cross out f of x, and I'm going to replace it with what f of x equals. So f of x equals 5x. So now I have g of 5x. And now that I did my inside, I can do my out. So g of 5x, now because I'm talking about g, I go to my g equation. And instead of x, I'm replacing x with 5x. So I'm replacing the 5x with this x here. So I'm going to have 5x squared. I need to have parentheses around this 5x because the squared is going to go to both terms. Plus 1. Now, in this problem, I can distribute that squared term because there's no addition or subtraction. To the front office, please. D'Angelo Hurtado to the front office. Sorry. Okay. So I can distribute that squared term because there's no addition or subtraction. So 5 squared is 25. X squared is just x squared. And plus 1 on the outside. I can't combine like terms. So this is my final answer. Don't forget to actually distribute that squared term to the 5 and the x. A common mistake is students just say 5x squared. But I'm squaring that entire 5x term. So Notice that when you switch the order, it's not necessarily the same answer. So composition of functions are not communicative. Let's go through this number 2. Okay, so A is asking h of p of 3. So I'm going to go from the inside out. So if I'm starting from the inside, that means p of 3. Well, I know that I have to replace this x then with 3. So that means this part right here is going to be 3 plus 2. So that means 3 plus 2 gives me 6. So I'm replacing this p of 3 with 6. So I'm left with h of, oh my gosh, 3 plus 2 is not 6. 3 plus 2 is 5. Jeez. Okay. So now that I did the inside, done with the inside, now I have to do the outside, which is the h part. So h of 5. So I'm plugging in 5 for the x. So I have 5 squared, and 5 squared is equal to 25. Okay, now let's go to part B. Part B is saying I want h of p of x. So I'm not actually specifying a number there. So if I have h of p of x, well, I already know p of x is x plus 2. I don't have to plug in any number.
Mr. Bulgari. Students, I want to make sure that when the bell rings, you guys head to class, that you guys are picking up trash and doing a good job for this next 2 days. I want you guys to be on your best behavior. And if you guys do that, I'll give you Monday off from school. All right, so do a good job. And I'll let you know tomorrow if you got Monday off.
Okay, I'm really sorry, guys. Okay, so now this x plus 2, I'm replacing with the x in the h equation. So I'm replacing the x plus 2 for that x. So I have, this is going to equal x plus 2 squared. Don't distribute this 2. Because of this plus sign, whenever we're adding or subtracting, we don't distribute the 2. We have to write it out. And then from here, I can distribute. This gives me x squared plus 2x plus 2x plus 4. And I can combine like terms. And I get x squared plus 4x plus 4 as my answer.